families, addition and subtraction bonds to 20 today. I'd like to play a game. Let's play what is being represented here. Do you like my fancy banner? Okay, let's go on with the game. What's being represented here? Did you say 5? That's right, 5. There is one hand, isn't there? I know that, so it could be 1, but 5 is what I'm looking for. Okay, it gets more difficult. What is being represented here? 15. Well done. 5, 10, 15. It's useful, isn't it, having 5 fingers on our hands? Makes counting in 5s really easy. Okay, gets more difficult. What is being represented here? Ooh, how many cars? See, I want to count in 5s, because I know that's a really good, efficient way of counting. But I can't seem to make 5s. Why don't I move some of those cars? Now I've got 5s. Rows of 5, 2 rows of 5, and a row of 4. Those 2 rows of 5, I could put those into a 10 frame. That makes it easier to see what's being represented. Have you got some cars, or something similar at home? Could you put them into a 10 frame? Could the 10 frame be parking spaces? That would be great, wouldn't it? I wonder how many cars you've got. What's being represented here? 20? Yes, that's right. We've got 10 at the top in the 10 frame and 10 at the bottom in the 10 frame. 10 and 10 is 20. So 20 altogether. But something's going to change. At the moment they're all red. And now look. Some have turned yellow. But how many? Well done if you noticed there were 9. It's 1 less than 10, isn't it? Or we can see 5 on the bottom and then 4 just above. 5 and 4 is 9. So I could have 20, but I also know that 20 is equal to 11 plus 9. We didn't take any away, none were removed, were they? So there's still 20 altogether, that's the whole. I've got 11 red ones and 9 yellow ones. So 20 is equal to 11 plus 9. Is there another way we can write that? Yes, that's right. We can have 20 is equal to 9 plus 11. It doesn't matter if the red counters come first or the yellow counters come first. It's still 20. What is being represented here? Not got 20 this time. I can see the 10 and 4 more. So 14. Yes, 14 is being represented here. 4 of them are yellow now. So 14 is the whole. And then that's something plus something. And then a second calculation, which I imagine will be very similar. Something plus something is 14. Do you think you can fill in those gaps? Why not pause the video here and have a go? How did you get on with that? 14 in this representation is equal to 10 plus 4. And then because we know 14 is equal to 10 plus 4, we know 10 plus 4 is equal to 14. What about these ones? First one's got 14 again, but a different amount of yellow counters. Our next one has got 15. Be careful, it's tricky because there's 15. And there's some yellow counters. And then the bottom one's got 15, and there's some yellow counters. Pause the video here and see if you can fill in those gaps. How did you get on? There's the answers. Well done, everyone. Creating a fact family. Fact families are made from 3 numbers. In this case, we've got the whole, 19, the red counters, 15, and the yellow counters, 4. We're going to slide these number cards into this number sentence. Pause the video here to have a go at putting it into your own number sentence. If you've not got number cards, post-it notes would be great for this. Did you do something like this? No, doesn't work, does it? 19 plus 15 isn't equal to 4. Ah, that's better. Our whole needs to come at the end of our number sentence in this case. So 19 is the whole, and then the other 2 numbers are the 2 parts, 4 and 15. They're the red counters and the yellow counters. 15 plus 4 is equal to 19. But there is another way we can do it. 15 and 4 are commutative. Our 2 parts can go either way round. So we could have 4 plus 15 is equal to 19. So what about subtraction? Same 3 number cards, 19 the whole, 15 the red counters, and 4 the yellow counters. Can I just slide them into my number sentence? Pause the video here and have a go. Yes, that's right. You can just slide them in this time. 19 subtract 15 is equal to 4. Last time, when we looked at addition, we swapped the first 2 numbers round because they were commutative, like this. Can you do that with subtraction? No, that's right. 15 counters, take away 19 counters, doesn't equal 4 counters. 19 subtract 15 equals 4. So 19 counters to start with. So the other way we can do this calculation, instead of taking away the red counters first, we can take away the yellow counters. So 19 subtract 4 would give us 15. It's the same 3 numbers. There are actually 8 calculations in each fact family, and they all contain those same 3 numbers. Here, our whole is 17, 1 part is 7, that's the red counters, and 1 part is 10, that's the yellow counters. Our top row shows us addition calculations. We started with the whole here, 17, and we've said 17 is equal to 7 plus 10. On the other side, we started with the parts. 7 is a part, and 10 is a part, and 17 is the whole. So swapping where our whole goes allows us to create 8 calculations for each fact family. 4 additions and 4 subtractions. Pause the video here and see if you can fill in those missing blanks. Remember, it's always going to be 17, 7 and 10. Good luck. How did you get on with that? Here are the answers. Well done, if that's what you got. I've changed my representation on my 10 frames at the bottom. I've got 7 red counters and 6 yellow counters. Here's part of my fact family. This works really nicely with a part-whole model. Part-whole model connects our whole to the parts. In this case, we've got 2 parts, 7 and 6. And what we can do is cover up any one of the 3 parts and use the other 2 numbers to calculate the missing number. For example, I cover up 13, I can add my 2 parts, 7 and 6, and find my missing number, 13. If I cover up one of the parts, I can start with the whole and subtract one of the parts, 6, which leaves me with 7. So I can always find my missing part. The other place that this works really nicely is a bar model. So here I can take my whole and put it into the bar, and then the two parts are going to fit under that hole. Now the proportions don't have to be exact with this. All we're showing is that the two parts, 7 and 6, when added together are equal to 13. Their bars are the same length as the 13 bar. Can you pause the video here and have a go at writing the 8 calculations in this fact family? Good luck. Brilliant. Did really well. Here are the answers. And that brings us to the end of this lesson. If you've got the White Rose Maths worksheet, you could have a go at that now. Or if not, head over to the BBC Bite Size website for supporting materials.